No, I'm Dr. Richard Huntsinger from the Haas School of Business, University of California-Berkeley, and author of Business Analytics, Methods and Cases for Data-Driven Decisions from Cambridge University Press. The book is for business students interested in data science. It's for data science students interested in business. And it's for everyone, executives, managers, analysts, and academics interested in both. The book occupies the sweet spot between a cursory survey of business-oriented data science concepts and an in-depth study of statistical learning theory. Over 50 analysis and modeling methods are presented by appealing to intuition and demonstrating business applications, but they're backed up by an appropriate level of mathematical rigor, making the material accessible to readers with a broad range of backgrounds. Also, a rich set of online resources accompanies the book, so that instructors can conveniently stand up new course offerings and enhance existing ones, built around the methods and business cases. Chapter 1, Data and Decisions, sets the stage using data to inform business decisions. We introduce the topic like this. Consider the game show Let's Make a Deal. There's a fabulous prize behind one of three doors. A contestant randomly decides on one door, is shown what's behind one of the other doors not chosen, and then offered the opportunity to change the decision. Perhaps intuition would lead you to think that changing the decision wouldn't result in any better probability of picking the door with the prize. However, we can apply methods to data to reveal a pattern. On average, in fact, in this situation, it is better to change the decision. You'll win about twice as often if you do. Here, careful analysis of the data reveals insights that lead to a better business decision than intuition does. But we can't generalize from this one example. Consider an auction for an envelope filled with some unknown amount of money. You don't know exactly how much money, but you do have data that indicate that there's a 99% probability that it's $100. Also, according to the data, on average, there's more than $99 in the envelope. How much would you pay for such an envelope? It turns out that there's no way to reliably estimate how much the envelope is actually worth, even with these data, which is perhaps counter to your intuition. The data aren't wrong, they just don't reveal any useful insights that can help us with the specific business decision at hand. Throughout the book, to get us from data to insights that can usefully inform our business decisions, we adopt the data to decision process model as our guide. It prescribes construction of a decision model and sensitivity analysis, used in concert with data analysis and analytical modeling methods to arrive at quantifiably better business decisions. In this chapter, the process model, decision models, and sensitivity analysis are discussed in detail. In subsequent chapters, we study a wide variety of specific data analysis and analytical modeling methods in detail. Chapter 2, Data Preparation, looks into methods to represent data in ways that may be more conducive to analysis. We discuss data objects, selection, amalgamation, synthetic variables, normalization, and dummy variables. In this chapter, in the high-tech stocks case, we prepare a data set with selection, amalgamation, and synthetic variables to discover relationships among companies' financial performance in the high-tech industry. See here how adding carefully chosen synthetic variables to the data set exposes the average monthly return rate for investment in a company's stock. Notice that, in this representation, we more clearly see the need to use the geometric mean function rather than the simple arithmetic mean function to get an average number that would usefully inform a business decision. Chapter 3, Data Exploration, looks into methods to summarize data in ways that may be more conducive to analysis. We discuss descriptive statistics, similarity, cross-tabulation, data visualization, and kernel density estimation. In the Iowa liquor sales case, we explore a data set with descriptive statistics, data visualization, and kernel density estimation to discover historical sales patterns that could influence future product management strategies in the beverage industry. See here how constructing kernel density estimates using various bandwidths exposes the otherwise obscured sudden change in customer behavior in the fourth year. Customers buy more of the cheap stuff and buy more of the expensive stuff, abandoning the mid-priced products in between. Chapter 4, Data Transformation, looks into methods to alter data in ways that may be more conducive to analysis. Methods applied to alter data can be appropriate so long as it leads to insights that usefully inform your business decisions. We discuss balance, imputation, alignment, and principal component analysis. In the loan portfolio case, we transform a dataset with principal component analysis to discover relationships predictive of loan defaults in the banking industry. Without principal component analysis, none of the variables are very predictive. With principal component analysis, we find that just one new variable is very predictive, and so we can use it to make decisions about which loans to buy and which to reject. Chapters 5, 6, and 7 are about classification, ways to construct, evaluate, and use models that can predict categorical outcomes. We start by introducing a general classification methodology, with special emphasis on how to evaluate classifier performance with confusion matrices, cutoffs, and metrics using in-sample, out-of-sample, and cross-validation approaches. Grounded in the methodology, we then discuss 6 important machine learning approaches to constructing predictive models: k-nearest neighbors, logistic regression, naive Bayes, decision tree, support vector machine, and neural network. And we discuss how to enhance the binary classifier forms of these models to multinomial classifier forms. In the truck fleet maintenance case, we construct and tune predictive models using data balance, principal component analysis, and support vector machine methods to inform a new adaptive truck fleet maintenance schedule in the logistics industry. See here how the decision model, shown as an influence diagram, quantifies a business result, cost, as a function of the performance of the decision method. That is, in terms of how well our model predicts which trucks are healthy and which trucks are in imminent need of repair, based on data being broadcast from hundreds of sensors on the trucks. It's a classic industrial Internet of Things, or IIoT, situation. Without predictive models like these, the company would have to rely on unsophisticated policies that bring in trucks for repair on a regular schedule, whether they need it or not. Comparative analysis shows that, indeed, our predictive models can provide significant cost savings. In the facial recognition case, we construct a predictive model with principal component analysis and multinomial support vector machine methods to recognize people in photographs in the gaming industry. See here a few of 174 photos of some stand-in celebrities. The photos have been first prepared as a table with variables for every pixel, then transformed to just the first 7 principal components. It turns out that only 174 photos, represented by only 7 principal components, is enough data for us to construct a model that can identify 6 different people with 67% accuracy. With more photos and some model tuning, it gets even better. Chapter 8 is about regression, ways to construct, evaluate, and use models that can predict numerical outcomes. We discuss a general regression methodology, evaluation approaches, linear regression, and regression versions of a variety of predictive modeling methods. In the call center scheduling case, we construct and tune predictive models using linear regression to inform a partnership agreement between a large retail pet supply client and a business processing outsourcing provider. Here we have 2 different decision models at play, one from the provider's perspective that quantifies the provider's profit as a function of how well our predictive model predicts call volume, because good predictions of call volume enable the provider to schedule the right number of call center agents. Not too many, not too few. And another decision model from the client's perspective that quantifies cost savings and customer satisfaction as a function of the predictive model's performance. Does this mean that the provider and the client are in an adversarial relationship? In a way, yes, they're motivated by different business objectives. But in a way, no. It's a partner relationship. They each want the other to succeed to keep the business going. So, it's in both the provider's and the client's interest to predict call volume well. We have them work together to construct several predictive models using several variations of the linear regression method based on 1 year of historical data and evaluated on another year of historical data. Comparative analysis of the predictive model's performance makes clear that no one staffing policy would optimize the business results for both provider and client. But it also makes clear what the trade-offs would be for implementing one policy versus another. With this analysis in hand, provider and client can rationally negotiate a staffing policy that is perhaps not optimal for either, but acceptable to both. In business, there's always a trade-off and there's always a trade. Chapter 9, Ensemble Assembly, looks into combining predictive modeling methods. Working in concert, an ensemble of methods can often produce a predictive model that performs better than any model produced by a constituent method could on its own. In this chapter, we discuss the bagging, boosting, and stacking ensemble assembly methods. In the credit card fraud case, we compare predictive modeling methods to inform a credit card fraud reduction strategy in the financial services industry. Here we see how models produced by 6 different methods would classify a new credit card transaction as either legitimate or fraudulent, given information about the transaction represented by 2 principal components. Green is predicted legitimate, red is predicted fraudulent. And we see how a stacked ensemble model, comprising elements of the other 6 working in concert, would classify a new transaction. Chapter 10 is about cluster analysis, ways to usefully organize observations into groups. We start by introducing a general cluster analysis methodology, with special emphasis on how to evaluate cluster model quality. Grounded in the methodology, we then discuss 3 important machine learning approaches to constructing cluster models: k-means, hierarchical agglomeration, and Gaussian mixture. In the Fortune 500 diversity case, we use cluster analysis to expose race and gender diversity in Fortune 500 companies. With a dataset comprising hundreds of variables describing race, gender, and occupation across many companies, it's not obvious how companies are similar to or dissimilar from each other. But cluster analysis handily identifies 2 companies as very similar to each other in how race and gender are distributed across positions. Once we know that these 2 companies are special, we can dive deeper into analysis to characterize what it is that differentiates them from all the other companies. And finally, Chapter 11 looks into special considerations when working with special data types. We discuss text data, time series data, network data, PageRank, and collaborative filtering. In the targeting marketing case, we use network analysis with descriptive statistics for network data to simulate market adoption and inform a marketing strategy in the enterprise software industry. We explore various ways to identify key influencers and find that strategically applying limited marketing dollars to the key influencers leads to faster sales. The book is Business Analytics: Methods and Cases for Data-Driven Decisions by Richard Huntsinger, available at Cambridge University Press, Amazon, and other fine booksellers now.